Hey, good morning. So I've been working on this problem of the sensor mount, exercise number 4 in the book. I got a picture of it here, and I'm going to draw it. And we'll walk through how to draw it. And but a little piece of advice to start this out. The mistake that I made, that you may have also made in attempting to draw this item, was relying on the capability of AutoCAD to do for you what you may actually have to think about. Not meant to be pejorative, but I fell into the trap of, hey, AutoCAD, just do this for me. Where's my little green icon that I can click on? And the fact of the matter is, this geometry demands that we think about it from the standpoint of geometrically what's happening. So we need to go back to geometry. We need to think about parallelism. We need to think about intersections and arcs and midpoints and all those things that geometry teaches us about the properties of circles and arcs and angles and all that. Lecture aside, so let's get into it, and I will show you what in fact I'm talking about. So here is the drawing that we're recreating, and so I'm gonna come over here. I'm gonna center it on 0, 0, but I'm gonna bang in the stuff that we know. I'm gonna get it in there real quick here, as quickly as we can, and then I'll get into the key point where geometry becomes important. So we'll start with a line, and we'll go from, I'm going to center it on 0, so -2, 0 to 2, 0 for that bottom line, and I'll come up with a relative 0, comma 1.5 to go straight up. I'm going to end that line. I'm going to do another line from -2, comma 0. Again, a relative 0, comma 1.5 to go straight up. Enter to kill that. And I'm going to draw, let's draw a 1.5 inch horizontal line. So the one kind of in the center of the drawing. So another line from -0.75 in the X, 2.25 in the Y, to 0.75 in the X and 2.25 in the Y. So we get that line. Now let's draw the circles we can see. So there's one centered at -1, comma 0.75 with a radius of a half. I could have used diameter to do that, but we're going to repeat that for a 1, comma 0.75 with a half radius. And then we have two circles straight up. So we'll go 0, comma 5.5 with a radius of 0.75. And another one, 0, comma 5.5 with a radius of 1.5. All right, so that's all the easy stuff. Okay. Now the question is, these arcs here, right? The challenge is how to get the geometry we need, right? There is an implied tangency here, and here, and here, and here. Now it's not along the horizontal; it's somewhat below. So you can see the circle comes here, bam, and there it kind of inflects and turns. So there's some tangency down here. We don't know where it is. So what I was trying to do is use a tangent radius, or tangent, or 3 points or something to figure out how to draw these circles. Well, I say figure out, but to have AutoCAD figure out for me where to put those circles. And all I got was fail, 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 fail. I did find a kind of a brute force way to get as close as possible without going over, but it didn't ever actually put the points coincident, especially down here. I struggled with this point. So here's what we're going to do. We're going to look at the geometry of this, and we're going to say, okay, this radius here we know is 3.5. So there's some point out here that's 3.5 units from here. So let's use geometry now. So if I draw a circle centered on this point with a radius of 3.5, we know that the circumference of that circle will have to go through where the center of this arc is. Okay. Now, if we go up here and we look at this point of tangency here, I don't know where it is. It's somewhere on the circle, right? Don't know. But I do know that wherever it is, precisely at that point of tangency, that I am also directly in a line with that point. If I keep going, I am on this center here. And this center is 1.5 units from the point of tangency, which is 3.5 units from the center. So if I draw a circle centered here that has 1.5 plus 3.5 as its radius, then bam, I've got this big circle out here. And where that big circle crosses the littler circle, that must be the center of this arc. All right, so let's try it. Let's come over here. We're going to draw a circle. And I'm going to snap to end point for its center. Put it right there. And I'll go 3.5 on its radius. And then I'm going to I'm going to do it again. Repeat circle. I right click to repeat circle. I've got my O snaps on, so it finds the center. So I'm going to go on that center. And 1.5 plus 3.5 is 5. Bam. Right here must be, by the fundamental properties of geometry, must be the center of this arc. So I can either draw an arc from here, or I can draw a circle from here. So since I'm already in the mode to draw circles, I'll grab this intersection point, and it must be 3.5 units. Oh my goodness, you can zoom all the way in, and this puppy hits exactly, right? That's the problem I had before. I couldn't do that. So now we got this. So now we use our handy dandy trim feature, and we can get rid of this. So, well, let me do some more circles because this is fun. Circle. Now this arc, again, the point is here, not here. So I need to do the same thing, except I'm going to use this endpoint. So where am I? I'm in circle. So that's my endpoint, and that radius is 4.25. And then I need another circle here. Why am I not snapping to? There we go. And I need that to be 0.75 plus 4.25, or 5, right? Where'd my circle go? Did it draw it? Is it the same circle? Yeah, duh, same circle. 0.75 plus 4.25 equals 1.5 plus 3.5. So it's the same circle, and where it crosses this circle. Well, I need to trim this because it's getting too noisy. So let me modify, trim, and we'll do, I want this to be a limit of trimming, and this to be a limit of trimming, and then I want to trim this. Then I can get rid of this one, and this one, this one. All right, not gonna let me trim it, but I'm gonna kill it. All right, so okay, so I have this arc. Too many circles. All right, so this circle is the one I drew here. This circle is the one from here. So this point is now the center of the 4.25 radius circle. So let's ask for a circle. I want this intersection to be its center, and I want its radius to be 4.25. Bam. So now I'll go back to trimming, where this is the important part. So I want this and this. I'm going to grab a couple other things. Well, Let me do that. Those are my limits, so I can kill this. And then I can delete this one altogether. Oh, get out of here. Delete this. Delete this. Both of them. Remember I made two. There we go. One more trim. Where here's my limit. Here's my limit. Here's my limit. And I can kill this line. I can't kill that line. Let me do it again. Actually, that was dumb. Go back. I killed too many things. I got click happy because I need a line right here. I wonder if I can use extend. Can I extend an arc? Let's find out. I want that. There. Fixed it. All right, so trim again. And what I want to do is I want to trim this line. So there's a limit of trimming, there's a limit of trimming, and bam. All right, so I'm going to do the same thing on the other side. Circle centered here with a radius of 5, right? No, radius of 4.25. And then a circle centered here with a radius of 5. So I could have kept this one from before. I just needed to clean it up. All right, another circle centered here, radius of 4.25. Gives me that line. I'm going to erase this one. And I need to trim this one, but I'm going to draw the other one first, and I need a circle off of this one. That's 5. Remember we did that. That's the first one we did on the other side. Nope, this is 3.5. Sorry. Which gives me 3.5 from here, and then it's by definition 3.5 from here, right? Because this radius we know to be 5, and since this is 1.5 from here to here, let me show you this a little more clearly. From this center point to this point is 1.5. So then we know that from this center point out to here is 5. So that's why we do a circle of 5. Which if the whole distance is 5 and this distance is 1.5, then this has to be 3.5. So we can draw that tangent circle 3.5 here. So let's do that now. Apologize if I'm going too quickly. I'm very excited in my head because the solution that we're working through here, this method, it's not an AutoCAD method. It's fundamental geometry, and that's exciting when I think about it. That AutoCAD is a tool, and our knowledge of geometry is what's giving us the skills to solve these problems. Make sure I don't get too delete happy here. Whoop, I already got too delete happy, didn't I? As you can see, one of the problems I have as I work with AutoCAD is when the drawing gets too noisy, I kind of fall apart. So I have to periodically stop and clean it up. The circle can go away. The circle can go away. And I need this to go away. So here, here, here. Trim this. Ugh. I don't know why it didn't let me do that, but I'm just going to delete it. I need to trim. No. Trim from here to here. This line. And there you have it. So, again, in closing, the fundamental issue that I had with this, that you may have had, was trying to find some snap or other drawing ability feature built in here that gave us exactly what we wanted when we just had to stop and look at the fundamental geometry. If this arc, again, just in closing, if this arc is 3.5, we know that there's a circle centered right here, 3.5, and there's a circle centered right here, 3.5, whose intersections will define the center point of that arc. So once we figure that out, we can go draw those circles and then delete what we don't need. Thank you for listening, and have a good day.